All right, today we're going to do something really cool. We're going to build a machine learning model right from scratch. And I'm going to walk you through the entire journey from its very first simple guess all the way to a professional grade predictor. Let's get into it.
So let's start with a big question, a fun one. Can a machine actually learn to taste wine? I mean, obviously not by sipping it, but by just looking at its chemical data. Can it really tell a good wine from a not-so-good one using only numbers? Well, we're about to find out.
All right, so this is our project, the Wine Quality Challenge. We're using a really popular data set where the goal is simple. We need to predict a wine's quality score, which is a number from 3 to 9 using nothing but its chemical data. We're talking things like acidity, alcohol content, density, just 11 raw numbers.
Okay, so this is what we're working with. Each row here is a different wine. And see all those columns on the left? Things like fixed acidity, alcohol, and so on. Our machine has to learn how to use those numbers to predict that single quality score on the far right. That's the whole game.
Now, when you're building a machine learning model, you never ever jump straight into the deep end. You'll always start with a super simple guess to see where you stand. We call this a baseline, and it's basically the score to beat.
So what exactly is a baseline model? Well, think of it as the simplest, most basic shot you can take at the problem. It's not fancy, it's not tuned, but it is so important. It gives you a reality check, a starting point. It's the before picture in our model's transformation. And for our wine challenge, our simple little baseline model gets it right about 56.2% of the time. Now, is that good? Well, it's better than just flipping a coin, but honestly, we can do way better. This is our starting line. Remember that number, 56.2%.
So how do we beat that score? Where do we go from here? This is where the magic really starts. It's a technique called feature engineering, and it's basically the art of creating smarter data from the data you already have to give our model better clues.
So, check this out. On the left, you've got the raw data we started with, alcohol and density, two separate numbers. But what if we combine them? We can create a totally new feature, an alcohol to density ratio. Now, why would we do that? Well, this comes from a little bit of wine knowledge. A higher alcohol content for a given density or body often means a richer, more concentrated wine, and that usually means higher quality. We're basically giving the model a huge hint that it couldn't figure out on its own.
And this brings us to one of the biggest secrets in machine learning. It's this idea that smart feature engineering is almost always more powerful than just tuning your algorithm. It really is like, better ingredients are going to give you a better meal. Simple as that.
Okay, so we've got smarter data. Now we need a smarter process. And to do that, to really go from amateur to pro, we're going to use something called a pipeline. This is a game changer for organizing your work and, more importantly, for not making silly mistakes.
The best way to think about a pipeline is like a little data assembly line. So first up, the data comes in and gets scaled. This is super important. It puts all our features on the same playing field so one doesn't just overpower the others. Next, the pipeline automatically tunes the model, searching for the absolute best settings to use. And then finally, it trains the model on that perfectly prepared data. It's clean, it's repeatable, and it's way more reliable.
All right, let's recap. We started with a simple guess. We got clever and engineered a brand new feature. And we wrapped the whole thing up in a professional pipeline. So, did it work? Was it all worth it? The final results are in.
And boom, here it is. Remember our baseline, that little bar on the left? It was sitting at 56.2% accuracy. Well, look at our new Pro model on the right. We jumped all the way to 61.2%. Now, a 5-point jump might not sound like a lot, but in the world of machine learning, an almost 9% relative improvement from just a couple of smart changes, that is huge.
So, what was the secret sauce? What was the one thing that really pushed us over the top? You guessed it. It all comes back to that one feature we created.
And don't just take my word for it. Here's the proof. When we actually asked the model, hey, what was most helpful for you? Look what's at the very top of the list. Number 1,
Our own engineered feature, the alcohol density ratio. We didn't just help the model, we gave it its most powerful weapon. Okay, this is where it gets really powerful. The best part of all this isn't just the better score. It's that this whole process, from the baseline all the way to the pro model, isn't just a one-time thing. You can turn this entire workflow into a reusable blueprint.
And what does that mean? It means this whole thing becomes plug and play. You can literally take this template, change just 2 or 3 lines of code, like point it to a new data set and tell it which column you want to predict, and bam! You can run this whole professional process on a completely different problem.
So, why go to all this trouble? Why is having a blueprint like this such a big deal? Well, for one, it helps you avoid really sneaky and common errors, like something called data leakage. That's where your model accidentally cheats by seeing the answers during training. It also makes sure your results are reproducible, so anyone can get the same results you did. Plus, it gives you an amazing head start on any new project, and just keeps you aligned with how the pros do it.
So there you have it. We've gone on this incredible journey from a simple, almost random guess to a powerful, professional, and reusable blueprint. And these core ideas, start simple with a baseline, get creative with your features, and be disciplined with a pipeline, this isn't just for predicting wine quality. This is the playbook for so much of classical machine learning. So, now that we've got this down, are you ready to take